Hi everyone! Today let's talk about session 9.4, minimum spanning trees. So last class we talked about how to find some spanning trees using the breadth first method and the depth first method. Okay, so today we want to find the minimum spanning trees. So here is an example. The weighted graph G below shows the 6 cities and the cost of building roads between certain pairs of cities. So the goal is to build the lowest cost road system that will connect the 6 cities. So because we want to connect all the cities, so this is a spanning trees, and it must contain all the vertices because so that each city is in the road system. It must be connected so that any city can be reached from any other. It must have unique simple path between each pair of vertices. Because if a path contains multiple simple paths between a vertex pair, then it could not represent a minimum cost system. So this guy must be a tree. It's a spanning tree with the minimum weight. Okay, so let G be a weighted graph. A minimal spanning trees of G is a spanning trees of G with minimum weight. Okay, so here I draw some pictures of 2 spanning trees. Let's find out the heights. Okay, so look at the first picture. We have 6. Oops, let me change back my color. Okay, so we have 6 and 3 and 2 and 4 and 5. What are these? So 6 plus 4 is 10, 3 plus 2 plus 5 is 10, so that gives us 20. So the weight of this spanning tree equals 20. How about the next one? We have 2, 3, 4, 2, 1, right? What is that? That gives us 12, right? And you can see the weight here is smaller, so we have a smaller weight for this tree. So sometimes a graph might have different spanning trees, and we want to find a minimal spanning trees because we want to minimum our cost. Okay, so there are several algorithms for finding a minimum spanning trees, and let's explore the Prim's algorithm. Okay, what is that? So this is our example, okay? So first, let T be the minimal spanning trees. First, suppose it's empty, and then we add vertices and edge to it, okay? So first thing, let's add vertex 1 to T. So you can start with any vertex because a minimum spanning tree, it contains all of the vertices. Right? So you can start with any vertex, it will work. So we add the vertex 1 to T, and the edge incident to 1 is here I have highlighted the vertices, okay? So the edge incident to 1 is 1, 2, 1, 3, and 1, 5. Okay, and what other weights? 1, 2 has weight 4, 1, 3 has weight 2, 1, 5 has weight 3. Okay, and then we want to add the minimum weight edge. So which one is minimum? So this guy is minimum. Okay, so far so good. So this is the first step. We found the minimum is 1, 3, so we add 1, 3 to it. So far, so good? Yes. So add 1, 3 right here. So that's why we also add the vertex 3 to T, and then the edge incident to 3, except 1, 3 are 3, 5, 3, 4, and 3, 6. Okay, let me change different color, then you can see my different steps. So there are 3, 4, 3, 6, and 3, 5. Okay, so this is second set. What are the weights? 3, 4 is 1, 3, 6 is 3, 3, 5 is 6. Okay, and then you want to add the minimum. So which one is minimum? When you count the minimum, you count the edges that we haven't added to it. Okay, so you count this guy, this guy, this guy, this guy, this guy. Which one is the minimum? Well, this guy is the minimum. So we add the edge 3, 4 to T. Okay, so 3, 4 is right here. So which means we add the vertex 4 to T. And then the edge incident to 4 is, okay, incident to 4 is 4, 2 and 4, 6. Okay. And then 4, 2 has weight 5. 4, 6 has weight 6. And then you want to add the minimum. So minimum, you're not only looking at these two, you're looking at all the ones that we haven't added to the spanning tree. So we want to compare this guy, this guy, this guy, this guy, this guy, this guy. Which one is minimum? So this is minimum at this step, right? So that's why we add, oh, actually we have two of them are minimum, 1, 5 and 3, 6, they're both 3. So we can add 1, 5 or 3, 6 to the minimum tree, okay? And let's add 1, 5. Okay, here I put or, we don't add both of them. Each step we only add one edge. Okay, so let's see, add the vertex 5. So 1, 5 right here. So add the vertex 5 there, and then the edge incident to 5 are, let's see. Okay, so incident to 5 are 5, 3 and 5, 6. But you don't want to count 5, 3 because 3 is already there. You don't want to create a cycle. So we only add 5, 6. 5, 6 has the, let's see. So 5, 6 has the, weight 2. Okay. Now let's compare. So, which one is the minimum? Actually, this guy is the minimum. So we add 5, 6 to T. Now you see here why we cannot add both. So don't add both 1, 5 and 3, 6. Because 3, 6 is, the weight is 3. So it won't get a minimum tree. So you either add, so here you either add 1, 5 and 5, 6. Okay, so let me put here. So we either add 1, 5 and 5, 6, or we add, if we choose 3, 6, then we will choose 6, 5 in this case. Okay, so here we have we have created two minimum spanning trees, so they are the same weight. Okay, so be careful. Each step only add one edge and one vertex. Okay, and then each step you're gonna check, okay, among all the remaining edges, which one has the minimum weight. All right, let's continue. So we add the vertex 5, 6 is right here. And oh, you see, we almost have all the vertices except the vertex 2. Okay, and here you can see if we add the vertex 6, the edge incident to 6 are we don't need 6, 4. We don't need 6, 3 because it will create a cycle. So we just need to look at what are the edges that are incident to the vertex 2. Okay, so because we still need to connect the two. Let's use this color. Okay, so because we only left with vertex 2, let's find the edge that are incident to 2. So incident to 2, we have 1, 2, and 2, 4. So 1, 2, and 2, 4. 1, 2 is 1, 2, and 2, 4, we already have it. So let me highlight it. 1, 2 is right here. Okay. And 2, 4 is right here. Which one is minimum? So minimum is 1, 2. Okay, so 1, 2 is 4. So that's why we add this edge. Now we have include all the vertices. Okay, so we'll add 1, 2 to T. Now we are done. So far, so good, everybody? Okay, and let's draw our results again because this graph looks like quite messy, right? We have 1, and we have the 2, we have the 3, we have the 4, we have the 5, and we have the 6. Okay, so this is our graph. So far, so good. And I believe this graph is exactly this guy. We already calculate the weight equals 12. Okay, and in fact, we have shown this is the minimal spanning trees. Okay, let's continue. All right, next example, we want to find the minimum spanning trees. Okay, let's see. So remember, in order to find a minimum spanning tree, you can start with any vertex. You will get the same result. Okay, so start with, let's say, vertex A, and then the edge incident to A let's see, AB, AC, AD, and AE, right? So AB, AC, AD, and AE. AB has the weight 3, AC is 8, AD is 4, AE is 7. So this is the first step, right? And which one is minimum? Well, the 3 is minimum, so we add AB to T. So because we add AB to T, let's add the vertex B to T. So AB right here. Okay, and then the edge incident to B are B, C, B, D, B, E. Let me change a different color so you can see more clear. So B, C, B, D, B, E. Okay, and this is the second steps. And BC has weight 10, BD has weight 9, BE has weight 2. Alright, so among all of these, okay, which one is minimum? 2 is minimum, right? So we add the BE to T. Well, if we add BE to T, it means we add the vertex E to T. Okay, next. Okay, the edges incident to E are AE. AE we already have it. And then EC. Oops. EC and ED. So far, so good. EC is 5, ED is 1. Okay, and then we compare all of these edges, right? Which one is the smallest? Well, the 1 is the smallest, right? So that's why we add the ED to T. Okay. And then so we add the vertex D to T. The edges incident to D are AD, BD, and CD. But we already have AD and BD. And so we just need to add one more. That is, let's use this color. That is DC. So DC is 6. Okay, so actually you can see we have reached the vertices A, B, E, C, D. We only remain C. Okay, so let's look at the edge incident to C. What are these? Well, we have AC, BC, EC, DC. Which one is the smallest? Ooh, the smallest is EC, right? Okay, so that we add EC to T. EC is right here. Okay, now we have complete our spanning tree. If we want to draw our results again here, so we have A, B, E, C, and D. Okay, so in your homework, I strongly recommend you to keep this table in mind. So each step you're gonna add one edge and one vertex, and then you want to find the edges incident to that vertex, and then compare the weights. And then each step you're gonna compare the weights of all the previous steps that are not minimum, that we haven't added before. Okay, so you not only compare the weights of within that step, you also need to compare all the previous edges. So far, so good, everybody. Okay, so this is this example, and here we have more examples. Do you want to do some more examples? Let's see. How about let's do this one? We still have some time. Let's do this one. Okay. And this one, let me see. Okay. This one, I will leave it as exercise. And let's do the, okay. Let me insert. Okay. All right. Okay, so let's do this one. So first, let's add okay, let me, do I have orange color? Okay. All right, so step 1, we want to add the vertex A. Okay, we want to add vertex A, and then the edge incident to A are AH, AB, AF. AH, AB, AF. Okay. Let me see. I might need more space here. So let me put it here, because yeah, so in general we don't have the table given, then we need to keep those in mind and write it by ourselves. So AH has the weight, oops, let's see, okay, so this is 8. Okay. And AB is 12, AF is 5. Then the minimum is 5, so we want to add AF, okay? We add AF, which means we add the vertex F. Okay, so this is the first one we add. And then look at the edges incident to F are FE, right? So FE has weight 18. And then you compare which one is the minimum. So the minimum is the 8th one. So AH. Okay, so minimum is AH. So that's why we add the AH to it. So like here. And then because we add AH, so which means we add the vertex H. And then the edges incident to H are HB, HG, and HK. So HB, HG, and HK. HB is 9, HG is 4, HK is 47. Well, then you compare all of the remaining, okay? So, yeah, let me put it down. So all the remaining that I haven't put minimum there before, okay? So there are 12, 18, 9, 4, 47. Of course, the 4 is the minimum. So minimum is HG. So that's why we add H. So we add HG in it. Then the next step, we add G, the vertex G. How about the edges incident to G? They are GB, GE, and GM, right? GB is 3, GE is 7, GM is 13. Okay, so then we compare all of the edges, remaining edges, okay? And then the smallest is this 3. So the minimum at this step is GB. Then we add this GB right here. So we add GB, then we add the B. So, and then we look at edges incident to B. Incident to B, there only BE left, right? Because all the other vertices we already included in our minimum spanning tree. Okay, so BE has weight 9. Okay, let's compare all the remaining. We have the 12, 18, 9, 47, 7, 13, 9. So 13 is the minimum in this case. So minimum is GE. So minimum is GE, we add GE. Okay, so 6 steps, we add the vertex E, and then the edges incident to E are EM, okay? Because all of the other vertices, G, B, F, we already included in our minimum spanning tree. So EM is 26. So far, so good, everybody. Okay. And let's see. Here you can see we only have the vertex M and K left. So when we compare, let's compare the edges incident to M and K. Okay, M or K. So let me highlight here because it's not quite clear. So AB, no. FE, no. Okay, K right here. And so M and K, M and M, okay. So far, so good. So we compare HK, GM, and EM. So which one is minimum among those three edges? Well, that is the 13 is minimal. Let me use a different color in this case, okay? Because we don't pick the rest because we already include those vertices in it. Okay, so in this case, this guy is the min. Here we only left with vertex K and M. So that's why we compare the yellow highlighted edges. So we see the minimum is GM. We add the GM in it. Okay, so which means the 7th step we add the M. All right. Then adjacent to incident to M, we have the incident to M, we have EM. We already include EM and KM. Oh, so EM EM is we already have vertex E, so we don't need to include EM. So that's the KM. KM is 34. Okay, now we only left with the vertex K. So we want to decide is either HK or KM. Well, HK and KM is minimum. So let me write it down. We compare or KH or KM. And this is 47, this is 34. So this is the minimum. So we add KM. Now we have done. Okay, so we're done. We get our minimal spanning tree. So there are A, F, and then H, then G, B, E, M, K. Okay, so this is our minimum spanning tree. Okay, I hope this example can help you. Like what happened? How do you do your homework? You're not given the table, right? But you can follow the steps. Kind of have the table in mind. So each steps you add a vertex, you compare the edges incident to that vertex, and then you pick the minimum ones. Okay. All right. So that is sessions 9.4. Okay, so we have talked about how to find the minimal spanning trees. Have a nice day. Bye.